Next, we're going to determine how many sig figs each of these have. You're going to put check marks under the known digits, question marks under the guesses, and then you're going to put them into scientific notation. So pause the video, give it a try, and then unpause the video when you're done to see how you did. Okay, so let's do all the check marks first. The rightmost digit is going to be the guess. So for example, for the first one, this, and this, they're all significant because they're all non-zeros. So the one on the right is our guess. These two are known. So this has 3 sig figs. We're going to do that first for all of them, then we'll go back and put them in scientific notation. Next up, all of these digits, the non-zeros are definitely significant. And then because this 0 is in the beginning, it is not a sig fig. So this has 4 sig figs. Here we have the 3, and then there's a decimal. So remember the rule that was non-zero, then a decimal, then all the zeros to the right of that are significant. So this would be 2 sig figs. 22 meter sticks is a trick question. These are meter sticks. They're actual objects. They're unlimited. That just has an unlimited amount of sig figs. So you can write that with like the infinity symbol if you'd like, or you could write it out, unlimited sig figs, or you can write sig figs don't apply. Any of those would be correct answers for that. We can put it in scientific notation, and we will shortly. Next up, the 9, the 8, and the 1, they're non-zeros, so they're all significant. Zeros in between non-zeros are significant as well, so that's that 0 there. And then we just have to figure out this last 0 here. Because there's no visible decimal point, this 0 is not significant. It's important, it tells us how big the number is, but it's not a sig fig. So this would be 4 sig figs. We also need some check marks. So we have check, 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 question. All right, the next one, this is a non-zero and a non-zero, so they count. There's a decimal, so it goes non-zero, decimal, all the zeros to the right of it also count. So this has 4 sig figs as well. Now, with the last one here, we have a decimal, and then we have some non-zeros, so they definitely count. And when you have a 0 in between, that counts. So right off the bat, we know these 3 are significant. The question is, what about the first and the last 0? Well, because there's a decimal point and then a non-zero, all the zeros to the right of that count. So this last 0 counts, but the first one does not. So this has 4 sig figs as well. All right, let's go through and put them in scientific notation. So here we have 2.12 times 10 to the second. And I got that from moving the decimal, which is here, over twice. So it's going to go 1, 2. Next up, here we have this. We're going to move it over once. So then it's 1.231. Because it's going to the right, it's going to be a negative. So this is going to be times 10 to the negative 1, since we only moved it once. This one moved to the left. That's why it was positive. Okay, so for this one, we're not moving the decimal. So it's 3.0 times 10 to the 0. Whenever you don't have to move the decimal point, you use times 10 to the 0 power. 22 meter sticks, we can still put that into scientific notation. We would just do 2.2 times 10, and then the decimal is here. We're moving it to the left once, so it would be a positive 1. Here we have the decimal, it's right here. Here we have the decimal, and then we moved it over 1, 2, 3, 4 times. So it's moving to the left, so it's positive 4 times. So it's times 10 to the 4th, and then we need to put in the number, 9.801. That 0 at the end is not significant, so we can't put it there. This 1.300, they're all significant, so we need to show them all, and it's times 10 to the 0 because we're not moving the decimal point. All right, last one. The decimal point is clearly right here, and we're going to move it over 1, 2 times. We're moving it to the right. That means it's negative. So it's going to be times 10 to the negative 2. And then we're going to write 7.080 because the last 0 is significant. This first 0 is not significant.